Hello, hello. Can you hear me? All right, it's working. All right, perfect. So, hi everyone. I'm Gabe. If you don't know me, that's my name. So, this is the intro to cloud security. So yeah, we're gonna get straight into it. So, I have to put this here, so it's illegal to hack stuff you don't own. So, don't do it. Thank you. All right, so this is our agenda. So, we're gonna start with the evolution of computing and what even is the cloud in general, and then we're gonna move into the providers and offerings and services that they have. And then we're going to go into some red teaming and some blue teaming. So, should be good. All right. So, now we're going to talk about the evolution of computing. So, we'll go back to the Jurassic period, the Professor Wilson period, and we'll talk about data centers. So, basically, imagine a large, loud, fan filled place with a bunch of computers and servers and stuff that you run your applications on. There's a lot of problems with this approach. It's hard to manage, it's hard to keep organized, it's annoying to be around unless you're some people. So yeah, it's extremely hard to scale. You can't just buy a new data center and it's built tomorrow. So if your application starts getting a lot more load and things like that, it's hard to handle things. So that's one problem with this approach. It's also very expensive because, like I said, you have to build a new data center every time that you have to increase power. And it's also difficult to have a low latency global reach. So, if you build a data center here in the US, somebody in China is obviously going to have more latency to your application than if you built a data center in China. So, yeah, also you might overpay. You might buy too much capacity, too much compute power, and things like that, and overestimate and actually end up spending more per month or per year than you expected. So, that's the problems with the Jurassic period. So now we're in a new era. We're in the cloud computing era. It is, the talk of the town, basically. Big tech companies like Amazon, Microsoft, Google, they let you use their huge data centers all across the globe that they built to deploy applications and services and run workloads in the cloud, is what it's called. So you can kind of think of the cloud as like a network for rent or infrastructure for rent, pretty much. This solves a lot of problems. It's easier to scale because you can instantly just, build out servers or whatever you need, build out databases, and they have a lot of cool services. So you pay a lot less money. You don't need to worry about scaling, and you have a global reach because they pay for the capacity. So that's the benefits of cloud computing. So now we're going to talk about the main providers. So we're not going to be talking about Alibaba Cloud or anything like that. We're going to talk about AWS, Azure, and Google Cloud. So AWS is owned by Amazon, obviously, and then Azure is owned by Microsoft. Azure is slowly closing the gap on AWS, actually. AWS used to have a lot more market share, but Azure is putting a lot of effort into security and things like that, and they're building out some really cool services. I don't like Google Cloud, but that's just my opinion. So it's third place. So now we're going to go into the common cloud offerings, if you will, the like bread and butter that every cloud is going to have. So it'll start with just networking. This is stuff that pretty much I feel most of you would be familiar with if you've ever worked within like a virtual private network or anything like that, which we have done a lot with Blue Team. I know for sure. I haven't been to many Red Team meetings. But yeah, so basic cloud network structure. So instead of a VPN, you're going to have a virtual private cloud. This is where you'll deploy your resources, public and private subnets, so you can deploy your machines, your databases, things like that inside of those subnets. Where it differs, like I said, is they have a global reach. So the way that it works is you have like your region, which for us would be like US East, and then you have availability zones underneath that region. So you have US East like 1A, 1B, whatever. And that's where you would deploy these VPCs. So if you're very comfortable with networking and things like that, you would do well in building cloud infrastructure. So next would be compute. So there's three different types of compute in the cloud that are common. You have your classic VMs, which a lot of us are very comfortable with. You could deploy your operating system configuration. You pick the compute power, and like I said, it's super easy to provision and scale these instances. It basically takes like maybe 3 minutes for it to boot up. So you actually manage the virtual server. The second offering would be serverless. So serverless is there's obviously still a server there. There has to be, but what they mean by serverless is like Amazon, Microsoft, Google, they actually manage the server for you. So you don't manage the operating system configuration. You don't manage anything like that. All you do is deploy your code or you build the resources out that you want to build, and you don't have to worry about the underlying infrastructure at all. So this makes it like very easy for developers to just spin up applications. And it's also a lot more eco-friendly because if a server is not running at all times, so like the way serverless architecture works is it's event driven. So basically it's based on like events. It's not always running like a VM. So it uses a lot less power, it saves a lot of the environment. So that's the direction that a lot of these companies are trying to go. The third and final compute, or at least of the most popular ones, is containers. So these are just package applications. The main benefit of containers is that they have consistent execution across all environments. And some of the ways that you would deploy containers is obviously like Docker and things like that. Kubernetes to orchestrate these containers at like a um, organizational level. So some of the services, I'm just going to name off some of them. You don't have to remember all of these names, but for VMs, you have like your EC2 and AWS, and you have Azure VM. Azure makes things a lot more simple with naming for some reason. They don't try to add like a lot of extra stuff. But for serverless, you have Lambda and AWS and Azure Functions. Like I said, they're pretty simple. And then you have like EKS and ECS that allow you to deploy containers in the cloud. So that's how you could deploy all these compute resources to run your workloads in the cloud. Next is storage. So, obviously storage in the cloud, there's a lot more than just like a simple like SQL or non-SQL database. There's object storage, which is basically for like your files, your images, your backups, your logs. And then you have block storage, which is attached to virtual machines. And you could actually take this block storage, back it up, and put it on all different machines so you can maintain persistence across your network. And when you power off your machines, the block store actually stays there. So that's also a benefit of it as well. Then you have your relational and non-relational databases. So these are just like your classic databases that you would have worked with if you've ever built an application. Okay, I thought that turned off. And then you have your data lakes and warehouses. So these are becoming very popular with like the rise of AI. Everybody needs a lot of data. A data lake is basically, you could just think about it as like a huge database that just holds stuff. So you could actually use your object storage as a data lake. But these cloud providers are offering more like specific for that purpose. So yeah, now we're going to continue to identity and access management. So this is like a huge deal in security. Very, very, very important and very easy to screw up. This is growing rapidly, and it's basically just allowing and managing users and groups who can access what resources in the cloud, who can manage users, who can manage, execution of code, who can modify things. And the way that that's set up is usually like hierarchy. So you have like your users, which are like the bottom, and then you can put those users into groups. You could assign them roles, and then you could actually go as far as like specific policies to attach to just one user. So, I mean, if you're like a red teamer, this would be very good for you to do privilege escalation on and things like that, because this is like your one-way ticket to, root, as you could say, in the cloud. So why would you ever care about the cloud? Why do you care? Well, I'm pretty sure all of us here want to get a job, and companies are spending a lot more money on this stuff. And usually business goes where the money goes. So there's going to be a lot more jobs here. And there's been a lot of breaches happening lately. So security in the cloud is like a very needed skill. So now we're going to get into actual security. So let's talk about the shared responsibility model. This is something that gets misinterpreted a lot. The customer is responsible for security in the cloud. So basically, Amazon and Microsoft, they manage these services, and they're responsible for the physical infrastructure. Like I said, you don't have to worry about physical security or anything like that. But what you do have to worry about is encrypting your data. Customer data is very important. You have to worry about your identity and access management. So you have to worry about actually maintaining your virtual private cloud security and the security of your resources. So patching and updating the operating systems on your virtual machines, setting up network and application firewalls, things like that. So that's the type of stuff that you would be doing in cloud security. So a good news for everybody here is that, yeah, like when you say like one customer affects another customer, yeah, they're responsible for the security of like their services. So like if somebody destroys like, let's say like simple queue service is just that's their first service they ever made. So let's say you have simple queue service, right? And some threat actor comes in and just like absolutely destroys it, and it like destroys the workloads of millions of customers. That's like AWS's responsibility. That's like 100% on them. Your configuration of like your resources and the way that you set up like your cloud infrastructure, that's on you. But the actual services themselves, that's on the cloud provider. Yeah. All right. But like I was saying, good news. That's actually a good question, by the way, because people confuse that a lot. Um, so the good news for everybody here is that traditional on-premise vulnerabilities still stand. So all the skills that you've been building and learning through this club and different teams and things like that, they apply in the cloud because, old service versions, bad operating system or old operating systems, vulnerable application code, all the good stuff that we know about, it still is going to get destroyed in the cloud. So now we're going to talk a little bit more fun stuff. That was more of an introduction. So we're going to go into a little bit of red teaming first. So, most of the time when you start your hack the box or whatever you do, try hack me, whatever you do, you're going to be doing scanning and enumeration. So you're going to be trying to find out what is even going on in the network. Well, the way that you do this in the cloud is in my opinion, is with the tool called CloudFox. I think this is a very good tool. It gives you a nice output like this and makes everything nice and simple. It can scan, I think it has 24 things that it can scan in AWS. So all the common services. It could actually scan IAM privileges, as you could read. And then it has a little bit for Azure, a little bit less than AWS, but still a good amount. And then GCP kind of just forgets about it like me. So we're just going to leave that there. But yeah, very good scanning tool. And it doesn't have any built-in exploitation. So it's not going to be like a Metasploit where you could kind of like scan and, exploit at the same time. All it does is just purely scanning. So now we're going to talk about actually learning this skill. So this is a really good lab. It's called Cloud Foxable. It was built, so Cloud Fox in general is built by Bishop Fox, and they're like a big security company. So yeah, they built Cloud Foxable, and if you like CTFs, you'll probably like this. And it's like a quick way to just pick it up and start learning. And it's built with infrastructure as code, which I think is really cool. So if you want to know more about infrastructure as code, you should come talk to me, and we could build a project. But yeah, this is Cloud Foxable. Yeah. So infrastructure as code. So infrastructure as code is basically allowing you to deploy and manage infrastructure through code. So you could take like there's multiple different infrastructure as code. There's like Terraform, which is like the most popular. There's Pulmani, which is like written in Go. There's AWS, Azure. They all have their own like cloud specific ones as well. And what it allows you to do is like you can write in code like, oh, deploy VPC here in this region and this, deploy this many subnets or deploy this EC2 instance or whatever. So all it does is just allow you to deploy infrastructure through code. So it makes it really easy to manage and change that infrastructure quickly because before infrastructure as code was a thing, you had to go into a management console, click and change things, it's just their management consoles all suck too. So it just makes things a lot easier. Yeah. Yeah. So when you set up so it depends. I guess it depends on what you're scanning. So like when I did the Cloud Foxable challenges, you actually start like the way that it works is the Terraform configuration. It like builds out an entire like AWS like account for you, kind of like you'll have your own account obviously, but it builds out like 27 different users and like all different types of like vulnerable roles and things like that and vulnerable resources that it deploys. So you'd actually be scanning. You could scan account level. You could scan service level, you could scan network level, like you could scan everything with it pretty much. It allows you to even scan like permissions, um, and yeah, basically everything. So it's a good like all around tool. Good question, both of you. Good questions. All right. So now we're going to talk about exploitation tooling. So this is the self-proclaimed Metasploit of the cloud, even though it only works on AWS. So I feel like that's a little bit counterintuitive there. Um, It's called Paku and it's by Rhino Security. Rhino Security also makes a lot of very good cloud labs. They have a bunch of different ones that I'll talk about towards the end. But this is like your, all-in-one exploitation package, just like Metasploit. And a side note that I thought was pretty cool is that it's the name of the piranha in the Amazon. So I feel like that's good branding right there, because you're in AWS. So yeah, Paku is basically your all-in-one Metasploit for cloud technologies. That's actually what the piranha looks like. So now we're going to talk about common modules. You can do a lot of crazy stuff with Paku. You can write malicious code in Lambda functions, and that's like serverless. So you could write like serverless malicious code. You could backdoor EC2. You could backdoor users, or you could set up backdoors in users and EC2 security groups. You could privesc as well with it. You can basically do everything with it. So anything that you would want to do that would, destroy a cloud environment, you could do with this. So now we're going to talk about some recurring cloud vulnerabilities or like concerns that you would say that are very common. So the first one is vulnerable IAM configurations. So like I said, IAM is like a huge deal. It's a thing that's coming up a lot in security. There's literally jobs specifically for just setting up and maintaining IAM matrices. And that includes like setting up rotating access keys to certain services in a cloud environment, over privileging accounts, and just overall just setting up your configurations improperly. It's hard to do. Like you would think for you setting up like 5 or 10 users, like that's easy to manage. But if you have 1,000 people that are developing or finance or security team, like you have to manage a lot of different groups, so it gets really messy really fast. So maintaining and managing IAM is a big deal. The second one is storage bucket exposure. So that's like your databases. A lot of these object-based databases, attackers really want to go after them because obviously they have files, they have backups, they have logs. So it gives them a lot of information. And public read and write databases are very common. People will misconfigure databases and stuff like that all the time, especially in the cloud. It's a lot of new stuff that people aren't really familiar with. I read this survey the other day, and it was like they surveyed like 10,000 AWS accounts or something like that, or they like scanned 10,000 AWS accounts, and 31% of them had like publicly readable and writable databases, which is pretty bad considering you could change that very quickly. And yeah, the last one would be access keys and credentials. So rotating credentials is very important. Maintaining non-static credentials is also important because you don't want the same access keys or private keys to be it all the time, like the same keys all the time. So, the reason this happens is because people post credentials in code, which is pretty funny. They hard code their secrets instead of doing proper secrets management, which is also very hard to do for a large organization. And then you have, public code repos for your infrastructure as code. People do that as well, which is also very silly to do. So now we're going to look at some things that have happened due to these misconfigurations and recurring vulnerabilities. So obviously, hackers love data, like I said. So, personal information gets stolen from the cloud like all the time. Think about like, big companies. You could have like a big pharma company that could be in the cloud. Like almost every company is in the cloud now. Social security numbers, credit card numbers, you name it, it can get stolen. And like I said, with that public read-write accessible database, all it takes is like one JSON policy change, like literally like 1 or 2 words, and you can completely change that. So that just shows like the lack of security care in a lot of these organizations. Another thing is Gen AI exploitation. So if you're in the cloud, you know, Discord interest group, you would have seen that I sent a article about this. These hackers are pretty creepy. Basically, what they do is there's generative AI applications in the cloud, of course. There's everybody's doing Gen AI now. So you have, a service called Amazon Bedrock in the cloud. This is where they exploited this. The way it works is that a user account buys tokens, and basically those tokens allow them to interact with the Gen AI application. So what a bad guy does is they come in and they steal those tokens and use them for their own application. So pretty much they have their own application somewhere else, and they steal tokens and put them into their application. And the stuff they do with it is pretty creepy. They set up like, illegal chatbot sites and things like that to make a lot of money. Usually, this is caused by it can be caused by a number of things. I mean, if your IAM isn't configured properly, this could also be due to access keys or like, private keys being in for too long. Previously, these exposed access keys or like tokens would be used for crypto mining with EC2 instances because, obviously money, or like SES, which is like the simple email service. You could fan out like thousands of emails in like an hour. They would be used for like spam phishing campaigns and things like that. Also, they would be used to actually just gain access into IAM itself if you have exposed access keys. So, yeah. And I've spoken to some people about this, some like DevSecOps engineers and some like security solutions architects. This is like a very big concern for the future, this Gen AI exploitation to use for these illegal sites. So now we can talk about serverless execution. So this is when you gain access to a service like AWS Lambda, like Azure Functions, that allows you to run code and pretty much anything that you could do in code with malware or anything like that. You could do inside of a cloud environment if you gain access to one of these resources. So yeah, anything that you would normally do as a hacker with code, you could do inside of these services. And this also draw a lot of things in the cloud draw back to IAM because how can a hacker run and execute code if your IAM is configured properly to the point where like only a developer account would be able to do that? Obviously, if they gain developer account access, they'd be able to do it. But like somebody in a finance department shouldn't be able to come over to a Lambda function and modify and edit it and things like that and be able to run code. So, setting up very stingent IAM is a challenge as of right now. Yeah.
Let's say you get a set of resources like lambdas, buckets, or whatever, and you get all the IAM laws. What would you look for to make sure that's secure?
So it depends a lot on the service. So what like as far as databases go, definitely public read write that definitely cannot happen. As far as serverless goes, serverless services, you would want to make sure that it's not like accessible by anybody. There's things in the policies. I don't know the exact like names of each one, but there's as far as like Lambda goes and things like that, there's definitely like execution policies, like who could execute this code or like who can modify and change this code. So if that's set to like all users, usually it'll be like all authenticated users. That's obviously a problem. Um, so yeah, it kind of depends on the service, I guess you could say. Was that a that answered it well? Okay. Yeah. So the object databases actually don't run any of that stuff because they're files. So like the way that object storage is set up is kind of like a blob. So that's why in Azure it's called like Azure Blob Storage. It's literally just like a conglomeration of files. Yeah, exactly. So like a lot of them do have the same offerings. They're just different names per se. So you would have like S3 and Blob are like the same thing. They're both object storage. So they would be used to just house they could house like logs, they could house like very like malicious data or not malicious, miscellaneous data that is not organized in any specific way. So it wouldn't be like key value or relational. It would just basically just be there in general. But yeah, that's definitely I would say like the most common one that gets exploited just because like files, obviously you're gonna have like, a lot of important things there. Also backups, that's like all important stuff. So yeah, I would say in my opinion that's the most common one. So now we're going to talk about some breaches. So this breach is called Cause Miss, and it happened to Microsoft Azure actually, and this was in October of 2022. There was a vulnerability found in Azure's Cosmo DB, and it was actually with Jupyter notebooks. So in Cosmos DB, Jupyter notebooks are like native to the database. So you could like write code and analyze data and things like that, do all your cool AI stuff. I haven't worked with Jupyter notebooks personally very much, but they're integrated in Cosmos DB, and they were left without any authentication checks. So anybody could just modify them or do anything to them pretty much. And Microsoft fixed this in 2 days. So I give them a lot of credit. That was actually pretty good. But, these could expose valuable secrets in the notebooks that maybe were coded by devs and weren't supposed to be seen by anybody else. And obviously, if you get access to a notebook, you get access to code execution, which is also bad as well. So, yeah, that was Cause Miss by Microsoft. Now we have two breaches back to back on the same clouds, spectrum, I guess you could say. The first one happened to AT&T, and this is actually in Snowflake. And I actually did not even know what Snowflake was. It's a cloud provider primarily used for data analytics and your AI operations. Um, and Snowflake takes absolutely zero responsibility for these back to back breaches, of course, as they would. But basically, shiny hackers, I don't know if you guys have ever heard of them. They're like a very popular threat actor. Pretty much, they targeted single authentication, so it all draws back to IAM again. Accounts that did not have multi factor authentication. And that apparently is the attack vector for both of the attacks I'm going to talk about. Um, but yeah, they stole 50 million customer and call records. And like I said, they attacked accounts that were not configured properly. IAM best practice would obviously be, using multi-factor authentication and things like that. So, you know, that costs them a lot of money, I'm pretty sure. Now we're going to talk about Ticketmaster, the exact same thing. So both of these happened in summer of 2024. And like I said, Snowflake takes absolutely zero responsibility for what happened. And they think that is not in their service. The exact same thing happens, and apparently they targeted single authentication accounts and broke into them, and they stole 28 million credit card details. So that's nice. Cost Ticketmaster a lot of money. So yeah, that was another breach that happened this year. So as you can see, these breaches are like pretty common, and they're happening more and more as time goes on. Um, Vulnerabilities in actual cloud services. The one that I saw with Azure, that's actually pretty interesting because I haven't seen anything like that yet with the Cosmos DB. So yeah, I thought that was pretty cool. So we've seen what, you know, the bad guys have as far as, you know, how they can attack us, what they can do, some of the common things that they would do, what has happened in the past. So now we're going to go over to blue teaming in the cloud. So the way that I'm going to do this side of the discussion is from like an enterprise lens. I'm not really going to do it from like a personal lens because I mean, I don't think many of us would be doing this personally. So before you can defend something, you have to know what's going on, you know? So you need to make network architecture diagrams. So this is a diagram from the one that I like. It's called Cloudcraft. And basically you plug in your AWS account and it spits out a cool diagram. So it costs money. So make sure you have like 10 emails like me and you get it for free. But yeah, it makes really cool diagrams. You need to know what's going on before you can defend something. So that was just a preface. So now we're going to talk, like I said, about organizational level cloud security design. So also, if you see any of these little yellow underlined things, these are all links to either like white papers or like MITRE or any of these security things. So if you want to click through the slides and read more about this type of stuff that interests you, then go ahead and click through and find it. But yeah, we're going to get into this. So let's get into it. So IAM, right? Implementing a strong identity foundation, as you can see, is extremely, extremely important. You need to maintain a very strong identity foundation. So how can you do that? If you're an organization, you have, you know, thousands and thousands of people. So there's a couple different principles that you're going to want to follow. The first is principle of least privilege. So accounts, like I said earlier, a financial account should not be able to go and gain code execution in a Lambda. Like it should not happen. So you need to have the minimal privileges required to actually do the job. And also, these permissions need to be reviewed pretty often because some things can just kind of get lost in translation over time. And, you know, somebody says one thing and it's incorrect. Obviously, you have thousands of people working. So, you know, yeah. Next thing to do would definitely be centralizing your identity. So, using something like Azure AD, using something like AWS organizations, which is basically just a copycat of that. You know, use these services to take all of your identities and organize them into one place. That's definitely best practice. It makes it easiest to see. You have a lot of people that you have to manage. So, you know, you got to do what you got to do. And also get rid of static credentials. Static credentials, obviously, when we were talking earlier, we know that static credentials lead to a lot of very bad things. So your credentials should be temporary as much as possible, or at least kept very well in secrets, which is also very hard to do. That's a whole nother thing. So, what are some tools that can help you analyze this? If you're an organization and you want to, you know, you didn't do this from the start and you know, want to start being better about security, how can you do that? AWS, I know, has IAM Access Analyzer, and it basically just gives you like a full out report on your IAM security, some things that could be misconfigured. But like I said, a lot of that stuff can kind of go under the wind because technically, like, you know, financial person inside of your company being able to access something might not necessarily be inherently a bad thing. It's just not the best thing. So that's why it's tricky. IAM is very tricky, but this will you know, help you build it on your side. Now, as far as the user side goes, multi-factor authentication is like a must. Also, if any of you guys decide to make your own cloud accounts and like actually do things, never do it with the root user ever. You should always have your own separate user. It's just best practice. So make a separate user and set up, you know, admin permissions for yourself, but never use the root user. You should only use root user if you're like paying for something. Don't use it. So yeah, but enforce multi-factor, strong password policies, all the good security stuff that we all know, you know, that all applies. Yeah. Yeah. Ooh. I actually don't know. I think you'd probably would need like some type of, at least at a minimum, an audit policy. that you're allowed to like use those tools. I know a lot of the times for like the organizational stuff, like as far as on my own account, even like the budget explorer and things like that for your account, even if you have admin access, you have to specifically go in and give yourself access to those like organizational policies. So I'm not sure if you could actually do that if you wouldn't necessarily have to be root, but you definitely would need a permission. Yeah. Yeah. All right. So the next thing would be traceability. So Blue Team loves logs, right? So in the cloud, there's three types of logs. You have your event logs, which is like your API activity and things like that. In AWS, this could be analyzed with something like CloudTrail. Actually, not something like that is what you analyze it with is CloudTrail. CloudTrail will spit out logs, and you could hold these logs for a very long time in S3 for very cheap. So there's not really any reason to get rid of your logs unless you absolutely have to. The next thing would be metrics. Metrics is like what percentage of my compute am I using? Well, if a hacker is, inside of your compute instance and is absolutely destroying it with crypto mining, if you have a CloudWatch alarm, you would be able to see these things. So setting up centralized logging is very important. The last type of log is network logs. This is what we're pretty much used to with Blue Team as far as like a VPN goes, and you can see the network in your or the traffic in your network through logs. So the best practice is to obviously, like I said, centralize these logs into one place. That could either be an object database, or maybe have a separate object database for each type of event. So yeah, set up alarms, automate it as much as possible. Use your scripting skills that you build here to build cool cloud scripts. So now we're going to talk about security at all infrastructure layers in an organization because you want to stop the fire before it starts burning. So we're going to go into the edge and network layer. So you might be like, well, what is the edge? The edge is what is closest to the user. So you would have your content delivery network, your domain name service, things like that. Securing the edge, you could set up DDoS protection. I know that AWS Shield actually gives protection at the edge, and it's a all-in-one like DDoS protection for like 4 different layers of the OSI model. So that's pretty cool. And also you should filter traffic at the edge. So let's say, me, I just started a nice shop in Gainesville. I started a coffee shop and I have a nice website that I want to have in US East. Why do I need a guy in Russia to be able to see my website in US East? There's absolutely no reason. He's never going to come to my coffee shop. So you could actually filter these things. You could say, I only want people in this region to be able to view my website. And that's what you should do. Obviously, for organizations, it's hard to do that, but that works for small businesses and startups. The next thing would be network controls. So like when you design your VPC, you're really going to want to make sure you take your time with your security groups, which is like how traffic can come in and out of your instances or your subnets and things like that. You want to take time to set that up properly. And you're going to want proper network access control lists as well, which is pretty similar. It's just for the network level. And then you're going to have setting up proper gateway policies. So the internet gateway is like how you access the internet and things like that. And just make sure you have proper routing and stuff. So next would be a compute layer. So there's 3 different types of compute, right? You have instance, container, you have serverless. So for the instance level, you can create something called machine images. So let's say I took an Ubuntu image. I can go in, I can harden that image, and I can use that image all across my network on repeat for as many instances as I want. So you definitely would want to do that. You would also want to make sure that you're patching your operating system configurations, and you could do your anti-malware stuff as well. Whatever you would normally do on a VM or a machine to harden, you could do it there. Next thing would be serverless security. So like I said earlier, function permissions, who can execute these functions, who can modify them. That's very key. Also API security. So the way that serverless architectures are usually set up is you have your front end, which actually is, client facing. And then it honestly just connects to like one API endpoint or like an API gateway that allows you to access all of your architecture. So maintaining API security is key. And lastly, container security, which actually might be the hardest one. There's a company called ChainGuard that was at Shell Hacks if you went. That was actually really cool. They build CVE checked container images for like all popular stuff like Java, Go. Well, Java's not popular, but you know what I mean. Go, whatever else. Yeah, they build container images for all that good stuff. So you can use those. If you don't want to use those, I don't know if you have to pay for them. I haven't tried yet. You should be scanning your container images often. And, orchestration security, like I said, Kubernetes is pretty hard and pretty easy to screw up. So getting very good at it is definitely lucrative. So now we're going to talk about the data layer. I'm going to keep this very simple. Keep your data encrypted. Keep people away from it that don't need to touch it. If it's in flight, make sure it's encrypted. and encrypt it as much as possible, but still make it useful. And that's pretty much the main premise there. So this is the developer writing the code that is going to absolutely destroy your network right now. This is the application layer. So how do you make applications secure? So this is like your application security. If you're good with AppSec, I mean, this is kind of unrelated to the cloud, so I won't go too deep, but you have your static and dynamic vulnerability testing. So static code analysis would just be actually scanning the source code, and then dynamic would be in an environment that the code is actually running. You're going to want to, make sure you're doing these tests and just make sure that you thoroughly test your code. There should be multiple eyes on it and things like that. But like I said, it's not too related to the cloud. So now we're going to talk about incident response in the cloud. So, something happened and your network's on fire. So you need to put it out. How are you going to do that? So if you've been to Blue Team, this is going to all sound very familiar because it is. So you need to be able to see an incident to respond to it. So this is where logging comes in. Like I said, logging is extremely important, should be set up early, and should be maintained very well. These logs should be automatically alerting you. Like I said earlier, you have to automate as much of the process as possible because too many logs, you're not going to have enough eyes to really scan them and comb them all the time, 24/7. It's not going to happen. Set up alarms, things like that. So an incident happened from that alarm. So, at an enterprise level, you need a plan. You need a very good plan. And you need a plan that is also going to work with not just your team, but also alert your customers. And you should, take responsibility for what happened, unlike some of these other companies that don't, like Snowflake. So you're going to want a very good playbook. Everybody should have, tools and things like that. But as long as you're going to Blue Team and doing the stuff there, I think you're going to be pretty well off with this. I mean, this is pretty much, what we specialize in. So, go to Blue Team if this sounds interesting to you. But after the fact, you need to analyze what happened, collect as much evidence as possible, like how we do with screenshots and things like that. There's better ways to do it, I think. But you're going to isolate the issue and you're going to figure out what caused it and you're going to fix it and your company's going to have better security from it. So you're going to want to document this entire process as well. But that's pretty much a very quick rundown of incident response. So if you want to get into this, go to Blue Team. It's pretty cool. So that was just a small incident response. Now your building is done. Your network is done. So what could you do? Well, this is where disaster recovery is very important. So the good part about not just having one data center that's physical is that disaster recovery becomes a lot simpler to set up. In the cloud, there's multiple ways to set up standbys and be ready for disaster recovery. Let's say you have, one network running in US East and then you have another network running in West. Just because it's running in West doesn't mean people can't access it from East. So you could use that network in the West in a multitude of different ways. So the lowest level of standby is a pilot light, right? So a pilot light is basically just minimal setup, core services only, easy to upscale and things like that. And, it takes the longest time to recover from a disaster, though. So that's the downside. The upside is it's cheap. So if you're broke like me, that's pretty good. You have warm standby, which is like your medium. This is always going to be running, and it's going to have syncs with the primary infrastructure, but it's not going to be like fully synced at all times. It's not like an instant failover. It's still going to take some time, and you're still going to probably lose out on some of that data that you would have been missing when your network was down and things like that. And your application will still probably be down, have a little bit of downtime. And the final and most expensive way to do it, which is how most enterprises will probably be doing it, is multi-site active. So this is where you take your network and absolutely replicate it with full redundancy to like another region or just have it in general twice. And it has automatic failover. So that's where like your CloudWatch logs and metrics and things like that come in. You could set up things called like health alarms, and they let you know if your instances are going down or like, if something's happening. And on those alarms, you just have failover automatically to the separate network. So yeah, it's the most expensive, but it's also not perfect because, applications will still go down and things like that. And you still will lose some data because syncing data over the cloud is actually hard. I tried to do it across clouds, which is actually pretty much impossible between Azure and AWS. It's very hard to sync data across two cloud providers. It's pretty hard. So yeah, data syncing between two different networks is a lot more possible, but it isn't like 100% like a full live stream of data just coming through. There is still some latency there. So I'm going to give you like a little mini roadmap. We have like 10 minutes left. So how can you build these skills? How can you build them quickly? What could you do? How could you learn cloud? There's like thousands of things going on. So the main thing is to just stay focused. Don't fall into the pitfall of trying to learn 1,000 services at once. Pick the ones that you could apply to a project. Maybe take Minesweeper and just put it on like an EC2 instance or something, or set up an IAM matrix yourself. It's free. You can make as many accounts as you want. It's not going to charge you money. So you take those accounts, set up permissions, play pretend and role play that you are an organizational owner, and set up a great IAM matrix and practice security. But yeah, main key point of this slide that I want to say is just stay focused and don't fall into a bunch of pitfalls that you definitely can with all these services. All right. Yeah. Oh, okay. So the way that I mean by that is like you would create like a cloud account, right? And so like IAM is like identity access management. So basically you could create like 10 different fake accounts and things like that, right? So you could like let's say you could just set up an account like user that's like a developer. You could set up a user that's like a finance person. And then you take all those users and you like set up security permissions pretending as if you were an organization. Yeah, through like AWS itself or like Azure. Like you just get on one of the cloud providers and you could create an account. That doesn't take too long. They're gonna make you put your credit card in. By the way, also this is like a myth. The cloud does not have to be expensive. It doesn't. You could do a lot of stuff for free. They set it up very well. Especially AWS makes it very easy to do things for free. Um, Please make sure that you set up a budget alarm. That's why I have that picture at the bottom. I found this guy on Reddit. And he got charged $60,000, and Amazon is suing him for it, and they want their money. So make sure that you set up a CloudWatch budget alarm for like $1. And if you hit $1, you better go turn off whatever's turned on. So, this way you don't get charged a crap ton of money. I did that early in my account because that's what I was worried about is losing money. So, but for you red teamers, inside of these speaker notes, I have a roadmap that was given to me by Adam about cloud pen testing and things like that, of all of the different things that you could do to build your skills. So I'm not going to read them all out. For the blue guys, you know, I've been struggling to find something that's actually good for blue teaming in the cloud or like practicing it and things like that. So what I did to practice it, like I said, was just kind of build projects and in those projects just be security minded when building them. That's all. And then after you do the basics, to dive deeper, what I recommend is like it sounds very boring and it kind of is boring at times. Read. They have a lot of white papers on AWS. They have a lot of documentation on Azure, GCP. I do not recommend GCP. That's my opinion. Please do not use it. Use the other two. Read about them. Learn more about them. And they have a lot of security ones as well. So that's pretty cool. Just do your research. And also, networking is very important for all computer science in general. If you're interested in a career, find a UF alum who does it and message and haggle them on LinkedIn to do a meeting with you and learn more about their careers so that you know what to do to become better. And don't fall for the certification trap. Do not go buying 10 cloud certifications because I convinced you that it's so cool that you want to do it for the rest of your life. Take your time to get certs. Do not just go money drop. And also don't fall for the gurus on IG that are telling you that you could do cloud in like 2 months because it's not true. I fell for the trap. Now I'm here. All right. And on a positive note, this is the end. Cloud is new. There's a lot of room for growth. There's a lot of room for you to build very cool stuff. Like I said, I mean, even the Metasploit of the cloud only applies to one cloud provider. So why not just make the one that applies to the other ones, or build something cool that you want to build? You guys have a great skill set. You're all pretty smart. You could do it. So yeah, that is the presentation. Hope you guys enjoyed. Thank you to the Zoom people.